Hey everybody, my name is Cyrus, otherwise known as 5Dogit online. I'm the guy who created Etheria, and I thought it might be worthwhile, considering there's a bounty out there, to do a video of how I built Etheria, and maybe you can build your very own Etheria if you like. First of all, what is Etheria? Etheria is the first ever decentralized virtual world and crypto real estate. Essentially, it's a virtual world of tiles, 33 by 33 map of them, and the state of this world is held entirely in the Ethereum blockchain. It has also been cut off from alteration in the world. You can buy these tiles and sell them and trade them or whatever with people. You can farm them and build things on them. This is my horse and some horse poo right here. Actually, those are horse parts that I didn't use. But this world cannot be altered anymore because it's been cut off from me and no one else can take it down. This is a tile owned by a guy named Frank Hold. He built a little cabin on here, which is cute as hell. Back in November, when I presented this at DevCon 1 in London, I bought this tile on stage and built the Microsoft logo on this tile. So all of this, where the bricks are, well, those are blocks, where the tiles are, what their elevations are, what their ooh, look, somebody did something down here. Nathan Hawkeye, follow him on Twitter. All this stuff, you know, everything that you see here is held in the Ethereum blockchain. So I'm going to tell you how this all happened. What you're going to want to do is go to github.com/5Dogit and go to Etheria. And if you look at the contracts in Etheria, you'll see Etheria 1.2, that's the main contract, and Etheria block depth storage and map elevation storage. Those are two subcontracts that the Etheria contract relies on for information. One stores the map elevations, the other stores the block definitions. So here's what you're going to want to do first is get a Geth instance up and running. I'm on Ubuntu Linux, and what you do is you install, I think the site is called Building Ethereum, and this will have the instructions for getting, well, that's CPP, you want to do Geth. Alright, and you click this link here, Ubuntu, and you do all of these. I would leave out the middle one. It looks like Geth is broken on dev right now, so don't do that one, but you want to install these repositories, then update, and then install Ethereum, or you can just install Geth by itself, sudo apt-get install Geth. Once you've done that, you want to run Geth, bang, and it starts propagating through the blockchain. It'll take several hours to go through. We're already at 954,000 blocks, so it's going to take you a while. Then what you do in another window is you type in Geth attach, like this. Geth attach. And then you can run a script to check all your balances. You probably won't have any. You might have to set up an account. I think that's probably outside the scope of doing this video, but you'll need an account to be able to execute all these commands to set up things on the blockchain. Alright, so the first step is we need to deploy and initialize the map elevation storage contract. This is the one that will hold the elevation information of all 33 by 33 tiles in the Ethereum blockchain. Alright, so just let's go quick through this contract really quickly. So contract map elevation storage, that's a declaration of the contract. UINT 1089 elevations. What does that mean? Well, UINT 8 is a type of storage. It is an integer, an unsigned integer, meaning it goes from 0 to 255. There are 1,089 of these in the array. Well, what does that mean? 33 times 33. Those are the tiles in the map. That's what 33 by 33 is. And you got your elevations here. Address of the creator. I'm going to store my address when I create this contract. This is the default constructor of the contract, and when it is created, the sender, whoever created the contract, which will be me, and was me, gets stored in this creator variable. All right, so then you have a really simple method here called get elevations. Once we've initialized all these things, we can just say, hey, give me the elevations for the whole map, and it'll return an array of 1089 of integers going from 0 to 255. That's what uint8 means. Then we can also we also have a little helper function here that says get elevation of a specific row and specific column. I said that backwards, column and specific row. It will return the elevations point. So since the array is not a two-dimensional array, I'd have to do a little bit of math here to figure out which one to return, but it's pretty simple. It's just the column times 33 plus the row. And that gives you the column row. The reason I do column row is that's XY. All right, and here's the real big daddy of the contract init elevations. We're going to call that 33 times. We're going to call it from 0 to 1, 2, 3, 4, all the way up to 33. And each time we're going to give it an array of 33 uint8s. Those are going to go in and set up the contract, set up the initial elevations of the contract. Now, in order to prevent me from getting in there and messing it up, after this contract has been locked, there's a simple method here that says if locked, return. So you can't do this if it's been locked. When we first create it, it will be unlocked. So what this will do is let's see, skipping through rows, and then there's a counter, and it counts up 33 times and sets those those indexes to the indexes that I've passed in. All right, so we're just gonna set up column by column by column. These are the standard lock and kill methods that I deployed with this contract. It has one Boolean that says, is this contract locked? So you can get that right here, get locked. You can also set locked. I could have done a check right here that said, only do this method if you are the creator of the contract. So it could say, if message.sender equals creator. But who cares? You know, I'm going to set this up and then I'm going to lock it. So I don't really need to make that check. And this is the kill. So if it has not been locked and I decide, oh, I got messed up, I initialized something incorrectly, or I don't want this contract out there anymore, anytime before it is locked, I can kill it. All right. So we're going to set that up. What we do is we take this contract, highlight the whole thing, all the way, everything below here is irrelevant. So we're just going to select all that, and then we're going to go to Chris Eth's browser Solidity. Chris Eth contract, or his website, which is amazing. Chris Eth is an amazing dude. And we're going to paste that in. All right, this is our map elevation contract. And we're going to compile this into bytecode. All right, the current Solidity version is this. Never used it before, but I assume it works. This is the code that automatically gets generated telling me how to deploy this contract. So I'm going to highlight this code, and I'm going to go back over here to Geth, and I'm going to say, create this contract. I guess that worked. We'll sit here for a few moments and see if it did work. Let's check on stats.ethdev.com and we can see, well, we could also look in here. Looks like 9 transactions happened in this block here, so I assume that it has happened. Nope, doesn't look like it has. We're supposed to get a callback here that says contract mined, blah blah blah, here's the address if it worked. If you don't see that after a few minutes, then something has gone wrong. Oh, there it is. See, it popped up. Now we have the address of the contract. We also have our contract stored as map elevation storage. So I can say map elevation storage dot get elevations of row 0. All right. Boom. There they are. 30. That's all of them. 1,089 elevations right there. I can also get the elevation of a specific tile. Let's say we want to get column 0, row 3. That's also going to be 0. All right. So what we want to do is start initializing all of these things. And the way we would do that is we would say map elevation storage dot let's see, what was the thing called? It was called init elevations. And we want to do column 0, and we want to send it an array of 33 things. Luckily, if you look back on my GitHub account, you can find that I've got a helper contract under extra. It's not a contract, a helper file that has all these set up for you. So we can say map elevation storage, send transactions, and then there's all these elevations to put in. Boom. And we just told the blockchain we want to send from our ETH Coinbase, our main account. Here's the gas we are willing to pay. I made a note here that it cost 232,000 before. That'll happen. Let's see, how do we check if that happened? We would say get elevation of 0, 0. Because we initialized the first row, still 0. Once that gets to set to 116, we'll know that execution happened. If it doesn't over the course of a few minutes, then that means we need to do it again and probably give it more gas. Nope, 116. So if we take a look at map elevations, get all the elevations, we'll see that the first row is all 116s. All right. So I'm not going to go through and set all of these again because I've already done it once and I know where my contract is stored. This is actually an interesting point. So how do we start interacting with a contract that has already been deployed? Good question. Let's go take a look. What we would want to do is look at the map elevation storage contract, and thinking ahead, I put all this information right there in the contract. Scroll down to the bottom and we can see that here's the bytecode and the Solidity version I compiled it under. Here's the ABI. This is important. It is the interface through which Geth is going to talk to the contract on the blockchain. So we're going to say var ABI equals, and then just cut and paste that in there. This is pretty much like what we were doing before, except instead of deploying the contract is already out there. Now we're trying to interface with it. So if we cat the ABI, we'll see that we now have a we now have a contract ABI, so we can interact with it on the blockchain. Now, the address of the contract is what we need next to be able to interface with the, let's see, go back to my document. I haven't touched Ethereum in a few months, so this will be good though. You'll get to see how to do stuff. So already, how can I interact with the contract? Gotta find this. All right, I found it. How do we interact with a contract that has already been deployed in the past? We set up our ABI, which we already did, and we say contract var contract equals the ABI at whatever the contract address was. And we know that because I published it in, there we go, in my contract. When you deploy yours, you're already going to have that information at the inside of Geth when you deploy it. All right, contract dot get elevations. Invalid address. Wonderful. Let's look this up. There we go. You got to put double quotes around your old addresses. So there we go. It's already been set up. So I'm not going to do all that again. Now we have our map elevations all configured. Now let's go back and do pretty much the same thing, but we want to do this for block definitions. Well, what are block definitions? Let's take a look on the Ethereum website. Here are the blocks that you can use on your tiles. And this is block 0. This is block 1. It's a horizontal beam. This is block 2. It's like a worm that goes from southwest to northeast, etc., etc., etc. These block definitions have to be stored somewhere on the blockchain so that conflicts and stacking inside Etheria can be calculated on the fly without taking up a gazillion bits of data. So all I have to do, let's just take the column for instance. Instead of having to store this hex and this hex and this hex and all 8 of these hexes in the blockchain and their location in space, all I have to do is store this one little hex here, and then my block definitions, which are stored elsewhere on another contract, can calculate, oh, if this is a type 0 block with a hex at coordinates x, y, z, we also know the other 7 on top of it are occupied. And that's why I did block definitions. It's basically a compression mechanism. All right, so we're going to go back to the 5-dogged Etheria contracts and look at block definition storage. All right, we'll walk through this one really quickly. So we got another contract definition. Come in here and we say, oh, blocks, what's a block? Well, we'll get to that. 18 of them, and we're going to call it blocks. Oh, here's our struct that defines what the blocks are. There are 2 parts to a block, a capital B block. One is, what does it occupy? It occupies 8 spaces in a 3-dimensional plane. So XYZ times 8. That gives you 24 spots that it's going to take up. So if we go back to the block ref, this would be, let's say, 000 and 001 and 002 and 003 and 0. So if I went all the way through that, I would name 24 digits. Attaches to, what the hell is attaches to? This can be variable depending on the type of block. Attaches to is the upper and lower points at which another block can attach. This is the stacking mechanism. So if we go back to the original block here, this has only 2. The block of type 0 has only 2 attachment points, the one beneath and the one above. So 0, 0, -1, and 0, 0, 8. Other ones will have more. So this one, the beam to the right, will have all the ones underneath it and all the ones on top. So it's got a total of 16. Well, 16 times 3 is, you guessed it, 48. And that's how you get to a 48. If it doesn't need all 48, then they're just zeros afterwards. See, first one is that, 0, 0, 0s till the end. All right, moving along, we're doing this again. In the default constructor, we are setting up the creator so that I can kill this if I need to. And then we go to function get occupies. So we want to look at, let's see, This is going to tell us it's a constant function. We know that. So that means that this is a function that is going to be called from the command line. Non-constant functions are the transactional functions that will change the state of the contract. Ignore what I said about being called from the command line. They're all called from the command line. Constants don't change the state of the contract. They only get information back. Ones that don't have constant are the ones where you send a transaction, you hit a non-constant function, then you're changing something inside of the contract. So what we want to do is these block definitions are just telling us get occupies. For which means which type of these, let's see, how many did I have? 18 blocks. I think it's 18. I thought I had a better graphics card than this. 18 blocks. Of these 18 blocks, what are its occupies? So we'll say for 0, you would get back the occupies are the one on top and the one on bottom. Here and here. For get occupies of which of type 2, well 1, we would get all the ones across here. I am totally speaking incorrectly. Occupies means the space that it actually occupies. So you would get 8 every single time. You would get 8 in response. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Those are the ones you get from get occupies. Sorry. Get attaches to is what I was saying before. The one below and the one above. Or for this block, you would have all the ones below and all the ones above. Those are important for the main Etheria contract to determine whether or not a block placement is valid on a given tile. All right, so there are 2 main functions here, it and it occupies and an it attaches to. Remember, we're not building Etheria right now. We are building merely a definition of what these blocks are and the space they occupy. So in it occupies, we would say which block and what are the occupies for that block. So we would go in here and we would say, oh, we got to interface with this first. So we would say var ABI equals, I'm going to go down here to the contract since it's already deployed. The ABI is this. ABI is also known as interface. So paste that in there. We now have the ABI. And we can do what we did before, which was set up a contract, web3.eth.contract, ABI. We've now changed that. And we want to set, we know that that contract is deployed at this address. Bang. Now we have our block definition contract. It's already been loaded up. So we're just going to do contract.get occupies of blocks of type 0, and you'll see that that's 000, 001, 002, 003, etc. That is the single column, this one. Whoop, whoop. All right. And we'd do that for all of them. Then we would go through and we would say, well, we don't have to do that for all. If we were setting this contract up for the first time, we'd say, let's see, contract dot set init occupies. This isn't going to work because I've already locked this contract, but init occupies. We've got these set up down here. Send, okay, block def storage. We know it's the contract init occupies. Send transaction 0, blah 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 blah. So what we do is contract.init occupies, send transaction, 0 is the first parameter here. Which one do we want to initialize? And then what is the space that it occupies? That's, again, we're doing the column. We're going to send this from account 0, not account 1. And we're going to give it some gas. Don't need to semicolon, so we hit enter. It's not going to do anything because the contract is locked. But that's how you would do it, and you would do that for all 18 blocks. All right? So then when you're done setting all those up, then you'd call contract dot set locked dot send transaction from your eth.coinbase probably to, well, you don't need a to because you're interfacing the contract already. Then you probably don't even need to give it gas because the default gas value would be plenty. And then you just go bang. But we already know this thing is locked because we can do this. Contract.getLocked. True, it's locked, so we can't do anything anyway. But now we have both of these initial contracts set up. Now onto the good stuff. We're going to deploy Etheria itself and get that bad daddy going. All right. Now this is going to be a little bit more complicated to get through. We have to define our block definition storage, which we deployed earlier, so that Etheria, this contract down here, understands how to interface with it. Similarly, we have to do that for map elevation retriever. There are only 3 functions, though, that the Etheria contract needs. It needs get occupies, and it needs get attaches to from block definition storage, and it needs to get elevations from the map storage. All right, so and these are just exactly the same definitions from the original contracts, except they just don't have any body. All right. Now inside the Etheria contract, we're going to skip this tile changed for one moment. We're going to look at these contract variables that we've declared. Uint8, that's his integer from 0 to 255. Map size 33. Pretty self-explanatory. Now we're going to declare a 2-dimensional array of tiles that are 33 by 33 large. That has not been initialized yet, but we're just making room for that. Now the creator again is me, and that will be set right here in the creation of the contract. Transaction.origin is pretty, in this context, is pretty much the same as message.sender. Transaction.origin means the original person who sent this if it bounces from contract to contract. But that doesn't happen here. All right, so block definition storage. We're going to set up our contract and declare it there. Map elevation retriever. We're going to set that up there as well. And then in order to give Etheria the information about how to interact with those contracts, we say block definition storage is this address and map elevation retriever is this address. Note there are no double quotes when you're inside of a contract. All right, so a couple of very simple getters to start out with. Function getOwner. At this column and this row, who owns this tile? Well, the tile struct knows all the information about its tiles. It knows its owner, it knows its name. My tile, for instance, is called 5 Doggett Hill, and I set that name up. Status is just like, what are you up to? I don't really know what I was doing with that, but the original plan was to have Twitter, a Twitter account that would send everyone status updates through the Twitter account and just let people who are participants in the Etheria world know. I never set that up and probably won't. All right, this is an array of blocks for each tile. That's why it's in the tile struct. But this is important. So this is a little bit backwards from regular JavaScript, where you would have rows and columns set a certain way. So if you were trying to access the 5th element in the first contract, first array, you'd say 0 and then 5. But in this, it's backwards. And that actually makes more sense. This, if you just look at it, this part right here, you would say, oh, I'm making an array of size 5, and those are of type integer 8, meaning negative 128 to positive 127. That makes sense, right? So then if you add another brackets around here, you'd say, oh, well, we're going to make an infinite array of what I just described. Right? This is not an array of 5 5 limitless arrays. It is a limitless array of arrays of size 5. That tripped me up when I first got to it. Hopefully it's clearer. Last farm is when was this tile last farm. It's important to keep people from farming their tile too often. And this is occupado, which means what are the, let's see, it keeps track for each tile which hexes are occupied. And that's in 3-dimensional space. So if you have a column at 0, 2, then you'd have 0, 2, 0, 0, 2, 1, 0, 2, 2, all of those all the way up to 8 all would fall into this occupado array. And again, this is an infinite array of integer 8 arrays of size 3. Got it? All right, so moving on. Get owner is for this column in this row. Who is the owner? We already did that. Set owner. This is important. So set owner allows the owner of the tile, right here, to give their tile to someone else. Originally, when I was setting up this contract, it had all this logic in it to ensure that that would allow people to make offers on other tiles, and you could accept those offers, and it got really complicated keeping track of all the offers and who offered what, and all that value had to be kept inside the contract to make the offers acceptable and the property tradable. And after a while, I just realized, why don't I just set this up so that I have one function that says set owner, and then outside, if you want to set up your own smart contract to do the whole deal with somebody, fine. But then all you have to do is call set owner from that contract to make it all happen. So inside, it would take the column and row that were specified and say, here's the tile. And if the tile owner is not the person sending this contract, then we reject that. And we say, what happened? This was not the owner. And then we return. The tile owner is the new owner. So when we send in the new owner, transaction origin is making sure that the person sending the contract saying, Etheria contract, set the owner of my tile to someone else. Just making sure that that person is the person who owns the tile. This new owner passed in is I'm saying, I want you to set it to this person. So that's why tile owner now becomes that new owner. We're going to fire this event called tile changed. That's up here. I can explain that later. It has to do with piping stuff out to a website or something that's listening to it, a console, etc. And then we're just saying what happened here. So what happened is just a helper variable that I set up so that I could tell what the heck was going on. You can call get what happened at any time to find out for the last transaction that came in what actually went on. Very helpful. It is the same for everybody, so if you're doing a bunch of stuff on Ethereum and everybody else is too, it might get all mixed up, but typically speaking, you're going to be the only one interacting with it at any given time, and it's helpful. All right, so get name. For this row and column, what's the name? Great. Set name. Again, it does a check to see if you are the owner. If you're not the owner, you cannot set the name of this tile. And then it says this tile changed. Information about this tile changed, and we're going to send that event out. More simple stuff. Get status. What is the status that has been set on this tile? And again, tiles, row, column, go get that status object or status property right here inside the tile struct, and then boom, we're done. Again, set status, same deal. Now, set status, I decided to make that have a value of 1 ETH to prevent people, if we were linking this up to Twitter or something, to prevent people from spamming. So it did have a value of 1 ETH. If you didn't send the value of 1 ETH along with that, then it would reject it. And if everything was good and you sent the right amount and you were the owner of the tile, then it would send, let's see, this is different. Oh, this is the owner check here. It would say, all right, let's set the status to the string that's coming in. send value to the creator. That would be me, person who created it. Say, I made a little money. Yeah. Nobody actually set their status. I didn't make any money. All right. And then you would fire the tile changed event again to let the etheria.world website know, hey, this has changed, and then go on. So now we're in the farming and editing category. Get last farm, pretty self-explanatory. When was this tile farmed last? Last farm, let's see. We'll find out how to set based on the current time. Oh, I think it went by block numbers. Yeah, so we'll show that in a second. This is farm tile. You get to specify which kind of block you want. So that's coming in, and we're saying at row and column, I want this type of block type, and I want to farm it. The very first thing it does is it checks, is this a valid block type? If you've put in a block type number that's less than 0 or more than 17, then you haven't selected one of these valid blocks here. So that gets rejected and your money gets returned. The tile is then brought up, and we take a look if it's the owner. Is the person sending this transaction in the actual owner? If not, return their money and say, you're not the owner. All right, now we take a look and say, when was the last farm? When did that occur? Every single tile starts out at 0. So block number right now is at 950,000. 950,000 minus 0 would definitely be less than, would definitely be greater than 2,500, which is about 12 hours of blocks. So we would go into this else category here. The point is, we don't want to let people just farm. But if you'll notice here, if they pay 1 ETH, then they can pay 1 ETH. They can actually do the farming, and it does not return. It'll go down here and do the farming. This is the else from you haven't farmed in 12 hours, so you get to do it regardless, and you get to do it for free. If they send any money, send it back to them, because we're nice like that. All right. Excuse me, I've had a cold. All right. So what we're going to do is get them 10 blocks of the type that they selected. We're going to loop from 0 to 10, and we're going to say increase the tile array by length 1 each time. And then we're going to set up the 5 values for a block. A block has exactly 5 values. Number 1, what is its type? 0 to 17. It's one of these. Number 2, what is its X value? Number 3, what is its Y value? Number 4, what is its Z value? And number 5, what is its color? Then once that's finished, that has gone, and we've set up all these values for the person. Then, by the way, these X, Y, and Z's are the key hex. That's this white thing here, right? So that's why they get set up there. Those all start out at Z -1, which means they're hidden. They fall underneath the green grass, and they will not appear at all. Even if they protrude above, they're just considered totally hidden if Z is less than 0. So they're initialized, hidden. Once they complete their farming, we take note of their last farm, which was just now. We fire a tile changed because there are new blocks on this tile, and we say we farmed the tile okay as what happened and return. Now, all of those blocks start hidden, so we have to provide the ability for a person to edit their blocks and move their blocks around. We say column row, what's your tile? You have to own your tile. And then what's the index of the block? We just got 10 of them. So right now, if we did, an initial farming of a tile, we would have 10 blocks. We would say this is our index 0 to 9. And then we would say we're asking in this function, give us the block information that you want. So for the block at, say, index 0, what do you want to do with it? What color is it going to be? What XYZ do you want to move it to? Etc. You cannot change the type of block. So we're going to go in here and we're going to grab the tile at that row and column, and we're going to do some checks. Do you own this tile? If not, return. is the Z location of the block below 0. It cannot be, you can't, meaning the incoming. So we're taking this block and we're saying, where do you want to put it? And if they have said Z is below 0, then screw them. You can't re-hide a block. That has to stay visible. Next check, is the index greater than the number of blocks we have on this tile? You can't edit a block that doesn't exist. If so, return, because that doesn't exist. And this is an interesting little check. It says, are you only trying to, let's see, block 0. If you specify the type of block, this is just a little hackaroo. If you specify the type of block, which would normally be 0 to 17, if you say -1 for that, then the contract will say, oh, okay, you just want to change the color. Leave the block completely alone where it is, avoid all the conflict checks, and just change the color of that block. All right? And I know I'm going fast, but you can go through and look at all this code yourself on my GitHub. So this is block 0. You can't change the tile, so we're just going to make sure that that is going to be set to 0 again, no matter what you put in. Wait a second. Oh no, we're just saying whatever it was, we're gonna set the incoming block to that value. You can't change it. All right, so this is where it starts to get a little hairy, and you're gonna just have to sort of figure it out. But I can tell you what this is meant to do. We are going to set up an array in memory of 24 and say, where did it occupy? Where was that block? Then we're going to say, where would it go? If we did exactly what you sent in through your information here in edit block, then we need to figure out where it would go. Then once we take that where would it go, we have to check that through this function to say, okay, looking at all of those hexes and where it would go, is it going to conflict with anything else? This is, as far as Ethereum calculation ability, this is pretty hairy, and this is where a lot of gas is spent. And it's important to note that if you, I lost my train of thought. So, blah, 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 blah. We're going to cut this out. Oh, if you have a block and you move it, let's say 1 over. Let's say you had this second block here and you moved it over by 1. Well, it would conflict with itself. The Etheria contract is not smart enough or powerful enough to move this out of the way, get rid of it, then place it and know that those blocks are open. It doesn't. All it would know is, oh, there's a conflict. So what you'd have to do if you want to move it over by 1 little space, and there would be a conflict with the block that it is, you have to move this down here, then move it back into the place where you want it to go. It's kind of a pain in the ass, but sorry. That's just the way it's got to be. Otherwise, you'd be doing all sorts of calculations, and you'd run out of gas. It wouldn't work. All right. So this is just hairy, but, you know, where would it occupy? Did it occupy anything that was already occupied? Is it a valid location? What happened is already set. If is valid. Okay, is valid location is a helper function that I've got down here. Utility section, is valid location. This is where it's doing a check to say blah, blah, blah. Does that block conflict with any other blocks that are there? And that's the would occupy. And then here it says, does it attach in a place? If it attaches to the ground, great, that's a valid spot, or at least a valid attaches to. If it does not attach to the ground, if none of its hexes are at a 0Z elevation, then you have to look for other blocks on the tile and see if they attach to that as well. And again, more hard maths to make all of that happen. This function here, is valid location, ends up calling is block hex coords valid multiple times, looking at each of the individual hexes, 8 of them, within a given block. So these are the block hex coords valid. Oh, actually, block hex coords valid is the boundaries. So this is doing a check to see if it at least that hex falls inside of the tile that you've owned, purchased, traded for, killed for, whatever. All right, so we're gonna go back up here and we're in edit block. We've done all the checking, everything checked out. Write or overwrite the hexes in Occupado. So we need to make sure that we're now recording that there are new blocks in these spaces. That's when it goes through all of these calculations. We got a nested loop saying we have to get rid of where it was before and then put in the new information, or overwriting. If the previous block was hidden, then it's not going to be in Occupado yet, and we just have to tell Occupado where it was. All right, get blocks, pretty self-explanatory. For this column and this row, what are the blocks? And then down here, this is the last one before the utility functions, by tile. Pretty simple. You send your money in. If you have not sent in 1 ETH, then you fail. Buy tile is only, ignore all this. This is old. I think this is old comments. You can only buy an unowned tile. If you're not buying an unowned tile, then you have to trade with somebody, and they have to call, as we remember before, they have to call the set owner function for you to now own that tile. So buy tile is only for unowned blocks, unowned tiles. Was it 1 ETH? If not, return their money and quit. If the address is 0000000, meaning it's unowned, then that's good. If the elevation is less than 125, that means it's a water tile, and you cannot buy that and return. And right here is where it says, okay, looks like this is good to go. We're going to fire the tile changed event, and then we're going to do what happened, buy tile, okay, and return. We already went through these utility functions. This is the one checking to see if a tile, if a hex falls inside the tile. This is the one checking to see if we conflict, the new block conflicts with anything in Occupado or and attaches correctly. This is the helper function to get what happened. This is just a quick fallback function to get money back if transaction orange on send message. Oh, this says if somebody accidentally sends money to this contract and they didn't specify which method to call, then just return their money. And this is empty. If any money gets stuck on the contract somehow, then at least I can get it back. Not because I'm being greedy, but because, you know, it shouldn't just hang out there and get lost. And then we got the standard lock kill methods. All right, so that is going to be the end of video 1, part 1. I may, don't hold me to this, I may make a part 2 that shows you how to actually set up a website with Node.js on how to deploy a virtual world and read information from the blockchain for your users. All right, bye-bye.